Solving systems of equations. A system of equations is two or more equations with common variables. The solution to a system of equations is the point or points where the lines intersect. There's different types of solutions that you can have. You could have one solution, no solution, or infinite many solutions. That would be like all real numbers. If you have one solution, that means that your lines are intersecting at exactly one point. If your lines are parallel, they're never going to intersect, so there's no solution. If your line is the exact same line as the second line, that means that they're intersecting everywhere. The equations are the exact same. The slope is the same and the y-intercept is the same. So that means that the solution is all real numbers. Here are a few vocabulary words to remind yourself of. Slope-intercept form, standard form of a line, x-intercept, y-intercept. The first method to solve systems of equations is to graph. Step 1. Identify the lines as line 1 or line 2. Step 2. Determine the slopes of the line. If they're the same, the lines will either be parallel or they'll be the exact same line. Determine the y-intercepts. If they are the same, the solution is all real numbers because they are the same line. If they're different, there's no solution because they never intersect. If the slopes are different, graph line 1 using any method. Then graph line 2 on the same coordinate plane. Approximate the coordinates of the point of intersection, and then check yourself by substituting those coordinates back into both lines to make the equation true. Solve the system of equations. First thing we'll need to do is to put these equations in slope-intercept form, which is y equals mx plus b. So for our line 1, we'll need to subtract x from both sides. Negative 2y will equal negative x plus 6. When we divide both sides by negative 2, y will equal 1/2 x minus 3. For line 2, we'll subtract 3x from both sides. So y will equal negative 3x plus 4. Now we can graph both of these equations. We'll graph the first equation by putting a point on negative 3 on our y-axis. We'll rise 1, run 2. Rise 1, run 2. Connect the points. And then graph line 2. For line 2, we'll put a point on 4 on the y-axis. This time we'll go down 3 and run 1. Down 3, run 1. Connect your points. To find the solution, you look to see where your lines are intersecting. I can see that our lines are intersecting at the point 2, negative 2. This is the solution to the systems of equations. Method 2 for solving systems of equations is to solve by elimination. Again, check to see if the slope and the y-intercepts are the same. That would save you time to see if the solution is no solution or all real numbers. So here are your steps. Step 1. Write both equations in standard form. Then, decide if the x's are to cancel or the y's are to cancel. It doesn't matter, you can choose. Determine the least common multiple of the coefficients of the terms that will cancel. You'll multiply one or both equations to make the coefficients of the chosen variable additive inverses of each other. That means the same number, one's positive, one's negative. Add the two equations and solve for that variable. Then take that solution for your variable and plug it back in to find out what the second variable will equal, and write the ordered pair. Solve the system of equations. X minus 2y equals 6. and 3x plus y equals 4. We need to decide if we want to cancel out the x's or the y's. It does not matter. Let's choose the x's. So the x coefficient is an understood 1 and a 3. I need to make them the same number but opposites. The least common multiple of 3 and 1 is 3. So I think to myself, what can I do to the first equation to make the x a negative 3? And I'll just need to multiply it by negative 3. There's no need for me to multiply anything with the second equation because I have the coefficient 3 that I need. When I multiply by negative 3, I'll have negative 3x minus 6y equals negative 18. We did not change anything about our second equation. So 3x plus y equals 4. I'm going to add these two equations. Negative 3x plus x will cancel out. I've eliminated the x's. Negative 6y plus y is negative 5y. Whoops. This should be a positive 6 because we distributed negative 3. So this will be 7y equals negative 14. When you divide both sides by 7, y is going to equal negative 2. Now that I know y equals negative 2, I can plug it back into one of the equations. It does not matter. I'm going to choose the first one. X minus 2y equals 6, and plug in negative 2 for y. So x minus 2 times negative 2 equals 6. When you subtract 4 from both sides, x will equal 2. So my ordered pair is 2, negative 2. The last method is to solve by substitution. You'll solve the equation for one of its variables. Substitute the expression from step 1 into the other equation and solve for the variable. Then substitute the value from step 2 into the revised equation from step 1 and solve. Check the solution in each of the original equations. Solve the systems of equations. 2x minus 3y equals negative 2 and 4x plus y equals 24. I can see that the y in the second equation is almost already by itself. There's no coefficient. So I'm going to solve for y. 4x plus y equals 24. I'm going to subtract 4x from both sides. This will give y equals negative 4x plus 24. Now that I know what y equals, I'm going to plug it into the first equation. 2x minus 3. Plug in your value for y, which is negative 4x plus 24, and this will equal negative 2. Now I just need to solve for x. Distribute negative 3 into your parentheses. Combine like terms. Add 72 to both sides. Divide both sides by 14. So x will equal 5. Now that we know x equals 5, plug it back into your first equation's revised. So y will equal negative 4 times 5 plus 24. That's negative 20 plus 24. So y will equal 4. Your ordered pair is 5, 4.